Okay, I'm going to go through some practice with logs to help you do a little bit better on some of these things. So 3 log base 3 of x minus 1/3 log base 3 of y plus log base 3 of z. We are trying to condense this thing. And so the key when we condense is we're going to rewrite that as just one log. So it's log base 3. If I have a number out in front, that's going to become my exponent. So now that's x cubed on the first one. The second one here, this part, because it's minus, the minus is going to take it into the denominator. So that y is going to go on bottom. The 1/3 is going to become the exponent. So it's 1/3 power, which is the same thing as the cube root, but we can just write it like that. This last part here, since it's plus, if it's plus, it goes in the numerator. So it's going to be log base 3 times z. That x cubed is on top. It was positive. The z was on top. It was positive. That is my answer. Number 2, we're rounding that thing to 3 decimals. And so what I want to do is I want to try to get x by itself. So first thing I'm going to do is add 3 to both sides. E to the 4x equals 10. Then I want to get rid of e. And we need to understand what the opposite of e to a power is. The opposite of e to a power is natural log. So what I'm going to do on each side is I'm going to take the natural log of both parts. So the natural log of e to the 4x and the natural log of 10. Ln and e, natural log and e, those two things are inverses of each other, like adding and subtracting, or multiplying and dividing, or squaring and square root. And so when they're next to each other like that, they're going to cancel out, leaving you with just 4x. And natural log of 10, that is just a number. In my calculator, I can take the natural log of 10. I'm going to type that in. That's some decimal, which is great, but that is not going to be my answer because that thing right there is equal to 4x. So if I want to get x by itself, I'm going to divide both sides by 4. So x is equal to the natural log of 10, close my parentheses, divided by 4. There's my answer, 0.576. That's solving that exponential. Next one, similar idea. Okay, maybe a little bit tougher, not crazy hard though. We're going to start off, these things are being multiplied. I can't mess with this yet because it's in the exponent. Before I do anything else, I want to get rid of that 4. Okay, we are thinking about PEMDAS in reverse, order of operations in reverse when we're solving. And so I didn't have an add or subtract step, so I didn't do that, but I did have a multiply and divide. It was being multiplied by 4. So to get rid of multiplying, I'm going to divide both sides by 4. Over here they cancel. 5 to the x plus 2 equals 500 divided by 4, which is 125. There are a couple different things of doing this problem from this point. Let's use our calculators because that makes this easy. And so to get rid of 5, I'm going to take the log base 5. 5 to a power. The opposite of 5 to a power is log base 5 on both sides. So in my calculator, I need to figure out this. Okay, and you don't have to use a calculator. I've got log base 5 and 5 to a power. Just like we did over here with ln and e, those two things are opposites. So are log base 5 of 5. When you take the log base of some number with that number to a power, those two things are going to cancel out to get you 1. And so all I'm left with here is that x plus 2. Okay, so all I have left is this x plus 2. Because this thing canceled each other out. And that is equal to the log base 5 of 125. Depending on your calculator, you can do that problem a lot of different ways. I'm going to do it the one that you probably have. I'm going to take the log of the number. So in my calculator, I'm taking the log of 125, close my parentheses, and I'm going to divide that by log of the base. Log of, I didn't hit log of 5. When I type that in, I hit enter, I get 3. And so x plus 2 is equal to just 3. I'm going to subtract 2 from both sides. X is 1. What else can we do? Now let's look at number 10. We are solving a logarithm. To solve a logarithm, if you have log written more than once, the first thing you need to do is condense it. So I'm going to condense it to have log base 3 just on one side. Then I'm going to rewrite this thing. It's this plus that. And so it's log base 3. If they're being added to each other, you have two logs being added, that is the same thing as multiplying. So 5, yeah, we'll write it the other way so it doesn't confuse you. X plus 2, this thing, times, because it was being added between two logs, it becomes times 5. It's all equal to 4. At this point, I can't touch any of this because that's all part of the logarithm argument. What I need to do next is get rid of this log base 3. And we learned up above that the opposite of log base 3 is 3 to a power. 3 to a power. So let me rewrite it so you can see what this looks like. 3 log base 3 of 5 times x plus 2 is equal to 3 to the 4th power. So what I did is I raised both sides with a base of 3 and made each thing an exponent. And so what I'm going to do next is on the left side, I've got 3 and log base 3. Those two things are opposites. They cancel. And so all I'm left with is 5x plus 2. Over here, 3 to the 4th, that is just a number. In my calculator, I can take 3 to the 4th power, and it gets me 81. Then I continue to solve. Distribute here. 5x plus 10 equals 81. Minus 10, 5x equals 71. Divide by 5, divide by 5. X is equal to 71 over 5. Solving a log. We condensed it first. When you have more than one log, we had to push it together to get me just one log. To get rid of log base 3, I raised both sides as 3 to a power. I did that in my calculator, 3 to the 4th power to get me 81. And then I reduced from there. I'm just looking around for other problems I could help us with. Number 9. Number 9 is the easiest kind. When we look at it, log base 3 is only written one time on each side. There's nothing else going on. Since that is true, if they both have log base 3, then I can just cancel them out, because I would take both sides and raise them to the 3rd power, or a base of 3 to that power. And so the 3 and the log base 3 would cancel on both sides, so that goes away, leaving you with just 2x plus 1 equals x minus 4. And then I can solve. I'd subtract 1. I'd subtract x. X is negative 5. So if you have just one log on each side, we can cancel. If you have more than one log, you got to do a little bit of work first. If you're evaluating and there's not a number, make it equal to x. I've got log base 5 over here. So to get rid of log base 5, I could raise each side to the 5th power, or base of 5, or I could just type that thing into my calculator too. I could take the log of the number, so the log of 1 over 125, divided by the log of the base, so divided by log 5. That's negative 3, because 5 to the negative 3rd power equals 1 over 125. X is negative 3. If I'm solving this one, it's log base 2. Log base 2, it's written twice. The first thing I'm going to do is condense it. So when I condense it, it's 4. This time it's minus. If you're condensing two logs and there's a minus sign, we're going to make it a division problem. X plus 3 goes on bottom is equal to log base 2 of 8. On both sides, log base 2, those two things are going to cancel. Now I've got 4 over x plus 3 is all equal to 8. I'll multiply both sides by x plus 3. And then it's just a solving problem. 4 equals, I can distribute here, 8x plus 24. Subtract 24, 8x is equal to negative 20. Divide by 8, x is equal to negative 20 divided by 8. Just solving there out once we condensed it. The key to this problem, though, is I had log base 2 written twice. And so I had to condense it into one log base 2. It was 4. Since it was a minus sign, I divided by the other part. I divided by x plus 3. When I had the same log base 2 on both sides, and that was it, then I could cancel it. And that allowed me to solve from there. I'll just make up a random one here. So 5 Let's not do 5. Let's do 2 to the 2x plus 4 is equal to 24. If I'm trying to solve that, 2 to a power, to get rid of 2 to a power, I need to get rid of the 2 to a power, and the way I do that is I take log base 2 of both sides. And so on both sides, I'm doing log base 2. Over here, those two things are going to cancel. I get 2x plus 4. Over here, log base 2 of 24, that is going to be a number. I can figure that out in my calculator. Again, I'm taking the log of the number, 24, close my parentheses, and divide that by log of the base. So divide that by log of 2. I type that in, I get this 4.585 number. That is not my answer, because I still want to get x by itself. So to get x by itself, I'm going to subtract 4 from both sides. So in my calculator, I'm going to hit minus 4. Cool. Still not my answer because it's 2x. So to get rid of the 2, I then divide both sides by 2. So in my calculator, I'm going to hit divided by 2. My final answer, x is equal to 0.292. Solving exponentials and solving logarithms. Hopefully that helps.